So with those preliminaries out of the way, I'm going to now show you how to implement a nearest neighbors classifier. And this is where it gets really cool. You build your first classifier in Python yourself. Neat. You're going to see everything you need to know to build one of these classifiers. So let's talk about the general approach. In a nearest neighbors classifier, to classify an example, you need to find its nearest neighbor in the training set. Or more generally, we may consider the k nearest neighbors classifier where you find the k nearest neighbors. For instance, if k was equal to 5, you might choose the 5 most similar examples in the training set. So we're going to have to write some Python code to go find those. And that's the first step we're going to do. We're going to figure out how to write and organize the Python code to do that. How would you do that? Well, I suggest the basic approach that you should take is, given an example, compare it to everything in the training set. And by compare, I mean find the distance between the example you got and each thing in the training set. That'll tell you how similar your example is to each thing in the training set. Then when you know those distances, if you want to find the nearest neighbor, the most similar one, what you could do is you can build a table where you record the distance. So now I have a table for the training set, but I add one more column that shows the distance to my example, and then I sort that table by decreasing distance. So that'll put, if I sort by increasing order of distance, that'll put the lowest distances at the top, meaning that'll put the most similar things in the training set will come to the top of the table. And if I want the k most similar, the k nearest, then I just take the first k ones in this sorted table. Okay, let's do it. Let's see what the Python code looks like. It's time to code. Okay, so we're going to write some code. And the first step when we write code is we're going to write a function. So you should write down what the arguments, the parameters to the function are, and what the function does. So in this example, we're going to write some code that, given an example and a training set, finds the k things in the training set that are the most similar, that are the nearest to this example. So the inputs to this function are pretty clear. This function needs to know the example, it needs to know the training set, and it needs to know k. How many of the most similar do you want? Okay, so I already wrote a comment to help me remember what this is doing. Now let's write the corresponding code. Well, ugh. This is a multi-step process I just described to you. We're going to have to write that down in code. That's a bunch of code. Anytime you find yourself thinking, I got to write a bunch of code, it's often a really helpful step to break it down into smaller pieces. And a good way to break it down into smaller pieces is define some more helper functions that do one of those smaller steps for you. Maybe does. Each individual step is its own helper function. In this case, the really tricky part is making that table that has the entire training set, but with an extra column for the distances. So I think what I should do is I should just assume that's been done. That's a separate step I'll have to do, and figure out what to do once it's done. And then eventually I'll have to write the code to do that. So to remind myself I'm going to have to write the code to compute that table, let me just write down, imagine I'm going to write a function to do that for me. What does that function do? Well, what it does is compute a table with a training set and distances to the example for each row in the training set. Okay, And next I figure out what are the inputs to this function and what is the output of this function. Well, I know what the output I want to be is. I want it to be this table that has the training set and the distances. So what does the inputs need to be so that it can do its job? This function is going to need to know the training set. So let's pass that as an argument. And it's also going to need to know the example that we're computing distances to. And that's all it'll need to know. So those will be the inputs. Those will be the arguments. And then I'm just going to remind myself, hey, Dave, at some point you're going to have to write the code for that function. Don't worry about it just yet. We'll come back to it. But we're going to have to do that in the future. So now I've set aside that work for the moment. Now I'm just going to imagine that I've written that function, and I'm going to figure out how to use it to find the k nearest, closest neighbors to a particular example. How do I do that? Well, the first step is let's compute that table using that function that we have yet to write. And then I said in my description of what to do, once you've got this table with the distances, you should sort them by distance. So let's sort them by the distance. And I'm going to assume this table has a column called distance. That's the distance to the example, distance of that training set instance to the example. So I sort this by the distance, and then what I just said before was once you've got it sorted, if you want to know the k nearest things to this example, it's enough to take the first k rows in this table. So we're going to take the rows, and we'll take the first k rows. And that's a way we can do that. So now we've got code to compute the k nearest neighbors, the k most similar things in the training set to our example. Awesome, we're doing great. Except, oh wait, one thing. We got to come back to how do I write the code for this function up here, the distances thing. I said I was going to do it later. Well, now, later is now. So, okay, now this is going to take a little more code. How's this going to work? Well, I've got a training set. I'm going to go through the rows of the training set, and I'm going to compare each row in the training set to my current example and compute that distance. So for this distance computation, we don't use the class. We don't use the label. We only use the attributes. So first thing I'm going to do is I'm going to take the training set, and I'm going to get rid of the class and keep only the attributes. And now what I'm going to do is for each row in that training set, I'm going to do something. And the something I'm going to do is I'm going to compute a distance. And the distance is going to be the distance between this row in the training set and the example that I now care about. How do I compute the distance between two things that I've got as rows? Well, here's where I'm in luck. I previously wrote code to do that. Remember, I wrote this function called row distance that will compute for me the distance between two rows. So I'm in great shape. I've got the current row of the training set, and I've got the example that I want to compare to, and I can compute the distance between them. Now, what do I want to do with this distance? Well, what I'm going to do is I'm going to create a list of all the distances. Okay. So these are the distances that are going to go in this new column in the table. So as I go through each row in the training set, I compute the distance between it and the example, and then I append it to this list, and that's going to be this new column. And now what I do is I take my training set and I add a column with these distances that I just computed. And my code that's going to use this function is going to expect there to be a column labeled distance. So that's what I'll make sure to do it. I'll call it distance using those values that I just computed. So ta-da! I now have code to compute, given an example and a training set, the k nearest neighbors to it. So let's take a look and work through an example and see how this works. If I run this code, I'm going to look at patient number 12 from my data set. There's patient number 12. and the values of all the attributes of their tissue sample. Okay. Now, that'll be the patient, the example that I'm going to try and classify. I'm going to imagine that this represented a new patient who's coming in and who's had a biopsy and a tissue sample, and their attributes are as given by this. And now I'm going to imagine that I want to make a diagnosis of that patient. Okay, so this is a patient, and there's the value of their attributes, and I'm going to want to use the k-nearest neighbors classifier to make a diagnosis. Let's just say this is just an example to work through and see what the code is doing. Well, the first thing the k-nearest neighbors classification rule is going to do is it's going to say, find me the k-nearest neighbors in the training set. Find me the ones in the training set that are most similar to this example patient. So we have a training set. Let's suppose our training set is all the historical data. We'll take this example patient, and let's say I want to find the 5 most similar patients in the training set. So that's k equals 5. Well, then I can run that code that I just wrote. Or I could, except that apparently I have a bug in my code. So what did I do wrong? Python is complaining at me because it says, says I tried to use attribute.rows, but the name attribute is not defined. Well, let's go look up here in my code. Sure enough, I tried to use this name attribute. I didn't define it. I defined a name called attributes. That's a silly typo. Let's fix my code and try again. All right, so this may happen to you when you write code. You may not get it quite right the first time. So you look at the error, and hopefully that helps you figure out what mistake you made. In this case, I didn't use the right name here. So let's try again and see if it works this time. Because I have a little bit of experience, I made a lot of mistakes with my Python code. I've gotten some experience with what kind of mistakes I tend to make, and I can spot pretty quickly what the mistake was and what the fix is. Don't worry if you don't spot it quite that quick. It's okay. All right, this time, fixing my bug. Now I have a working example. All right, so we can see that if I took a patient with these attributes and then I looked at all the historical data, the entire data set uses my training set, and looked for the 5 most similar patients in there. And here I get 5 patients. You can see here the attributes of these patients. You can see what their classes were. You can see the distance to my example patient. And we can see here that there were 5 similar patients, and 3 of them had a label of malignant and 2 benign. So if you took a majority rule, you might say, I think it's most likely that this new patient is malignant, because 3 versus 2. Okay, so that would be an example of how you might use this code for nearest neighbor classification. Now, if you're paying really close attention and you got an eagle eye, maybe you'd notice something a little fishy here. See this match, the number 1 most similar match, a distance of 0. What does that mean, and how did that happen? Well, what that means is the most similar to this patient is herself. Yeah, we took someone who was in the training set, and then we asked for the most similar, and sure enough, the most similar is herself. She's identical to herself. Her distance to herself is 0. So that was a little silly. This wasn't really a new patient. This was kind of an existing patient. So maybe we shouldn't have done that. So what you could have instead done was said, let's look at all, use as a training set, everyone other than this one patient, patient 12, and see who the most similar would have been if I left out themselves, so I don't end up with this degenerate match. And now we see here that there's 5 patients in the training set, the 5 most similar to this patient. And we can see that 2 of them had a malignant tissue sample and 3 were benign. So taking this into account with this adjusted training set, now the nearest neighbor classification rule would say benign. Okay, so this is how you could compute the k nearest neighbors, which was the first half of the classification rule. Once you've got the k nearest neighbors, that then helps you make a prediction, make a diagnosis. To get the full classifier, the way the full classifier works is to classify some example, diagnose some patient. First, we find the k nearest neighbors among the training set. I just told you how to do that. Then, using those k nearest neighbors from the training set, you look at the classes of them. We know the class of everyone in the training set. We know the diagnosis of all the historical patients in the training set. And we take a majority vote among those classes. Okay? We look at which class was most common. And that class is our prediction for what we think this new point should be classified as. That's the rule. So let's see how to write Python code that implements that. Okay. So we always get started by writing down, we're going to write a function to do this. So we write down what this function is trying to do as a comment. This is going to be the classifier, the classification rule, and we write down the inputs. So the classifier is going to need to know the training set, and it's going to need to know the attributes of a particular example. And in this case, it also depends on the value of k. And the classifier is going to find the k nearest neighbors and find the majority class, the majority vote among them, and use that as the predicted class. All right. So I told you how to do that. Step 1 is find the k nearest neighbors. Step 2 is find the majority class among them. Step 3 is return that as your prediction. So anytime you got multiple steps, it's often helpful to break those down into separate functions. And actually, I got you started. Because step 1 was find the k nearest neighbors, and guess what? We already did that. We wrote a function for that. We know how to do that. So the nearest neighbors, I just call that function that I already wrote. Nifty. Now, once I've got the nearest neighbors, I want to find the most common class among them. So I'm going to have to take the majority vote among the classes of those nearest neighbors. How do I do that? That's going to take some computation. So I think what I'm going to do is I'm going to write a separate function for the code that does that. That's a separate step, so we'll put it in its own function. And what that needs to know is the neighbors. Okay. So the majority class function is going to return the class that's most common among all of these neighbors. Okay. So let me just remind myself that I got to fill in the code to do that. And then once I've got that code, then now the classification rule will be easy. We'll be take those nearest neighbors and find the majority class among them and return it. Okay, so that'll be my classifier rule. I'm almost done, but I still got to fill in the code for this majority class function. So how am I going to do that? And I think here I'll just mention that we'll just use some table operations. The way we'll do that is we got a bunch of rows and we care only about the class. So we'll group them by the class. And then that'll give us a count of how many times each class appears. And we'll sort them. And that will bring the most common class to the top. And then we'll just grab that one. Okay, so let me just write out the code. I worked out in advance how to do this. So we group by class and then we sort. And we want to put the largest count at the top. And we only care about the class. And then we take just the first one, the most common one. All right. So now that is the entire code of a nearest neighbors classifier. And we can take that patient, that example patient we had before, and take the training set of everyone but that patient and see what this classification rule would predict. And the answer is it would predict benign, which is exactly what we got before because the k nearest neighbors were these 5 nearest neighbors, and 3 of them had benign tissue samples, so majority vote says benign. All right. Wow. That is the entire code of a machine learning classifier, the nearest neighbor classifier. And as we're going to see in a little bit, the nearest neighbor classifier is surprisingly powerful and effective. Even though we could write it in not too many lines of code, you're going to see it's pretty close to state-of-the-art machine learning classifier.